conversion is 80%. Now, using this particular experimental data, we have to design the commercial size reactor for a particular, for this specific reaction. And we have the option of that. Either we can design the fluidized bed or the packed bed. So using this particular data, experimental data, in this reactor, we can find out the kinetics. And using these kinetics, we will go for the design of the packed bed and the fluidized bed. That means nothing but the length of the packed bed or the catalyst requirement of the in the fluidized bed, that we can compare for the packed bed and fluidized bed. So for this particular one, if you say that find out the so for this MFR, tau, if you say that for catalytic reaction, is equal to, that is Ca0 Xa minus Ra also. Ca0 gaseous reaction. So Ca0 we can, how we can find out? Pa0 upon RT. So Pa0 is 1 atmosphere. So 101325 newtons per meter square. R is 8.314, and here it is temperature 336 plus 273. So this will, you will get the moles per meter cube. So it has the unit of what? Newton. What is the unit of this one? So accordingly, this will be in the mole per meter cube. So unit for R will be what? This is in the atmosphere. Is it? So you can do the calculations and get the value of this Ca0. So value of Ca0 will be around, you can do the calculation for this. What will be the value of? Okay. So it is 20. Then Ra, it is what? W upon Fa0. So Ca0 is the 20, Xa is 0.8, W is 0.01 kg divided by volumetric flow rate in meter cube per second, is it? Tau, this is nothing but W upon, is it? So you do this calculation. So it will be, what will be units? It will be in moles per kg second, is it? Yes, what is the value? 0.0064. Okay, you can check it all these values. Now, first we have to find out using this observed value whether it is strong or low or intermediate over resistance. So here we'll to identify this one, we'll use the Wagner module, that is MW. So in this case, this will be the diffusivity. It is given, okay, not mentioned. It is 10 to the power minus 6 meter cube per meter catalyst second. And also the density of the particle is given 2000 kg per meter cube. Okay. Now this will be the 0.0064 mole per kg second. L is given. It should be in the, if you convert in terms of the L, this will be in the meter square. Is it? For spheres, it will be L will be diameter divided by 6. So that's why it will be here 6 is coming. Then diffusivity, it is 10 to the power minus 6 meter cube per meter catalyst second. Is it? Into Ca is 20 mole per meter cube. Okay. Now, what will be the unit of this? If we do the calculation, what will be the unit for this? Yes, what is the value and units? Meter cube will get cancelled. Yes, it will be in the meter cube. Yes, someone has calculated. What is this value? 1 point. You can check it. Okay, others can check it. 10 to the power minus 5. Very well. You can check this. Now, this is the Wagner module. Okay, it has the Wagner. It has a 3W actually, Wagner, Weiss and Wheeler. Now this should be the dimensionless. This is per kg of the catalyst. So we'll use the density of the catalyst, that is a value. 2000. If you multiply with the 2000, what is this value? It will become dimensionless. Okay. So what is this value? It is 0.0256. Okay. So you can check. Okay. Now for this particular value, what is the value of effectiveness factor? If you refer the figures, or simply this is less than what? 0.15. What does it mean? If it is less than 0.15, it will become 1. So no over diffusion resistance. Okay. So RA will be equal to RA of C, whatever is coming. Now we have to design the packed bed with catalyst particles having the length they have mentioned it. Sorry, packed bed of this one. That means it will be the diameter of the particle. So what will be the L for this? (1.5 into 10 to the power minus 2 divided by, it will be dp by 6. So this will be the 2.5 into 10 to the power minus 3 meter. Okay. Now for this condition, we have to find out the Philemolus. Okay. From this expression, this RA observe is coming to be 0.0064. Okay. Reaction, it is a first order reaction. So this will be KCA. So Ca is in mole per meter cube. Ra unit is, so K will be what? And unit will be meter cube per kg second. Is it? So now this again you can convert into per unit time. Okay. So this K will be, you can multiply with the your rho. The definition of this Thiele module is K upon D. L is 2.5 into 10 to the power minus 3 meter. K will be, what is this value? 0.00, one more zero will be there. 0.32. It will be in meter cube per kg. So we have to multiply with the again density, that is 2000, divided by D. D is given in 10 to the power minus 6 and square root of this. Yes, so what is this value? Yes, this value is 2. How much? 2. Sure, it is 2.
Hello, sir.
Yes.
Sir, can you repeat once again why should we want to multiply by 2000?
What is the unit of K here?
Meter cube per kg second, sir.
Meter cube per kg second. And here it is D. It should be dimensionless. This K is given in the meter cube per kg of the catalyst. Is it? So to make it the dimensionless, you have to multiply with the rho, that is the density of the solid, that is catalyst, that is 2000 is given. So when you multiply with this one, it will be in the per unit time. So when you, here it is per unit time, it is meter square per unit time. So when it will be in the square root, it will be per unit length. That means per unit minute, per meter. Length has the, again, unit is meter. So it will become dimensionless because this value will be always dimensionless.
Thank you, sir.
Is it exactly coming to? Yes, is it coming to or something else? This value. If it is coming to, that means what? Intermediate is no strong, no, means without, it will be strong, not in the case of the strong core resistance, not in the diffusion free resistance. Okay, so using the particular figure, if you see that, where is that figure? You can get it for the 2. Yes, from this figure, for the value of, say that it is 2, spherical particle, if you take it, it is coming to be 0.4. Effectiveness factor is 0.4. I think it is figure 5 or 6. Epsilon will be around 0.4. So that means what? Your reaction is slowed by 0.4. So your K observed will be K into, so it will become 0.4 into whatever K, that is 0064 divided by 20 will be your K observed in the respective unit of meter cube per kg second. So for the first order reaction, W upon V in a packed bed, okay, for a packed bed, it will be kind of a, it is mentioned that 80% conversion, K value is there, the V is there, you can get the W value. So W is equal to, V is given as 4 into 10 to the power minus 6 meter cube per second. K will be in whatever this value, it will be meter cube, so effectively it will be in the kg ln. Ca0 is 20 and Ca will be what? 80% conversion. Is it? Is it? So this value you can substitute here. It will be 128 in 1.28 into 10 to the power. How much it will go? I think 10 to the power minus 5. I think. You can check this one. So this will be here. And what will be the weight of catalyst? Point 0.0503 kg. So it will be 0.0503 kg, or you can say that it is 50 gram. Okay. So similarly, you can repeat it for the fluidized bed. Same calculations. So fluidized bed and assume that mixed flow. So in this case also you can calculate. Spherical particles, then find out the Thiele modules. K is known. So what is the value of this Thiele module? Once you have, it is a mixed flow reactor. Assume that it is a mixed flow reactor. So Ca0 XA minus Ra. Okay. This here Ra will be epsilon A and C. Remember. So doing these calculations, you can reach to the value of W. So by comparing W packed bed and you can decide which one is the better. So this way you can, someone has done, I think Vignesh, and it is coming to be very good. So W is coming to be, yes, do it the calculations. In packed bed case, it is 50 gram. And what about this one? Do it the calculation. Yes, do it the calculation. What is the value of W here? Yes, what is the value? Do the calculation for fluidized bed. Yes, what is the value of catalyst loading? For fluidized bed, what is the value of empty? Empty is 0.133. Okay. If empty is 0.13, that means what? It is less than 0.4. So if it is less than 0.4, there is no resistance. So it will be 4 into 10 to the power minus 6, that is meter cube per second flow rate, into Ca0. Xa is 0.8, we need it. Ra is, K will be 3.2 into 10 to the power minus 4. Ca will be Ca0, 1 minus 0.8. Is it? So what is these calculations? Do it. $50 gram. So in both the cases, the weight of the catalyst requirement is 50. Then which one you would prefer? How you will select the which one is better, packed bed or fluidized bed, and why? Can you tell me? Anyone? Okay. You prepare this explanation. Now just take the one simple example. We have the reaction A plus B gives the two products R plus S. Second order reaction, gaseous reaction, 0.6 Ca into Cb, which is in the moles per kg hour. Now reactants are Ca0 is equal to 0.1 mole per meter cube and Cb0 is equal to 12 mole per meter cube. Now you have to calculate Xa and Xp. It's very simple, very easy react. Weight of the catalyst is given kg. Water flow rate is 10 meter cube per hour. How you will proceed? Recall your CRE1. It is a packed bed reactor. So for packed bed, Is it? This is for first order. But reaction is second order. How we can proceed? If you check that CB0 is far greater than CA0. So we can say that K, we can take it as a, that means CB0, CB will be equal to CB0 because A is the limiting and very small as compared to XB. So by assuming this first order reaction, K is equal to KCB0, you can use this equation and get the value of 1. So do this calculation. Let me see that. What is the value of this particular CK? Sorry. What we are calculating? Final equation will be again that Ca upon Ca0 is equal to minus K. So XA you have to calculate and XB. Yes, you can try it. This is just based on the CRE1.
C is equals to 0.94.
XA is equal to
0.94, sir.
0.94. Very good. And what about XB?
Zero, sir.
XB will be what? 0.9 or 0.80%. You say it is 94%. So it will be 0.8 something percent will come. Okay, you can do it this one. Those who have not done it. I have already sent the attendance record of all students. Just go through that one. Those who have a very less attendance, I suggest that be regular for the classes because there are few marks for the attendance also. And if you have any issues, you can say the network issues. You can just mail me that today we had facing the network problem, and because of that you are not attended the class, or you are not present full time, or what we can say that for more than 30 minutes. Okay. Okay, so there are number of other problems also in this one. You can try to solve it. Selected list of the problems I will give it after completion of this particular section. And from day after tomorrow, we'll start the new chapter. Okay. And if you have anything to ask, you can ask me now, or maybe you can WhatsApp or mail me or talk with me.